In this video, we're going to be taking a look at histograms, how to create a histogram, the general shape of a histogram, and what that means. Now, when looking at a large set of data, it's sometimes difficult to visualize where the data may cluster. So for example, do most of your data points cluster in the class from 200 to 210, for example? Or do your data cluster around the 300s? This is the purpose of a histogram. So a histogram will basically tell you the general shape of the distribution. For example, whether it's skewed to the right, skewed to the left, or if it's symmetric, unimodal, bimodal, or even multimodal. Now, a distribution that is skewed to the right just means that it has a long right tail. So most of your data values would gather on the left-hand side, and then they would skew off on the right-hand side. That would be a right skew. Now, if your distribution is skewed to the left, it's the opposite. So your left tail is then skewed. Most of your data values will gather on the right-hand side and then taper off on the left-hand side. Now, a symmetric distribution is one in which has a peak right in the middle and it's symmetric on both sides. That's otherwise known as the normal distribution or Gaussian function. Now here, in order to create a histogram, what you first need to do is create a frequency chart and then create the histogram based on that frequency chart. So create a frequency histogram for the following measurements that were recorded for the drying time in minutes of a certain brand of latex paint. The data values are given there. I want you to now pause the video and create your frequency chart and then your corresponding frequency histogram. Now remember, to create the frequency chart, what you're going to need is some class intervals. Now you'll notice here that your lowest value is 150 here, whereas your highest value seems to be 336. So you're going to have to kind of choose an appropriate class interval or class width. Now, since your lowest value is 150, I would start with the value of 150 and maybe choose a class of 50 width, so that your first class interval would be from 150 to 199, and then your second class interval would be from 200 to 249, and so on and so forth. So go ahead and pause the video now and create your frequency chart as well as your frequency histogram. So here I began to create the frequency chart. I created a column for my class interval, and then the next column is your class frequency. Now what that means is how many times do you see a value in your data points here that I'm circling that fall within, say, the first class here. So any values between 150 to 199, how many values do you see? I see 150, 168, 174, 168, 180, and 198 also fall within that class. So I see a total of 6 values that fall within that first class. That is then your class frequency. So the next class is from 200 to 249. So any values that fall within that class of 200 to 249, count them up. We have 204, 222, 240, 216, and that looks to be it. So your class frequency for that second class is just 4, because there's 4 values that fall within that class. Now so on and so forth. The next class is from 250 to 299. The values that fall there would be this 288, 264, and the only other one I see is 288 again. So my class frequency for this class is 3. Finally, the last class from 300 to 349, I only see 2 numbers that fall within that class. I see 312 and 336. So my class frequency for that class would just be 2. Now it's good to note that if you were to add up all values in your class frequency, what you should obtain is the actual sample size. So when we add up all these values here, you'll see that it adds to 15. Well, that should match the number of values in the raw data. And you see that there's 15 points here. So that just ensures that you haven't forgotten any values or left any out. So this here should match the total amount of data values here. Now in the last column, you see the class relative frequency. Now depending on your professor or your instructor, they may want you to create a relative frequency histogram as opposed to a class frequency histogram. Now the relative frequency histogram is just the percentage of points that fall within the certain class. So for example, in the first class here, from 150 to 199, I have a frequency of 6 values out of 15 that fall within that class. So your relative frequency would just simply be 6 out of 15. Now 15 is just the total amount of data points. Now 6 out of 15 just works out to be 0.4. And again, that's just the percentage. So about 40% of your data points fall within that first class. Now remember, you can always change a decimal to a percentage. All we have to do is move that decimal point 2 places to the right, and that would represent your percentage. So we have 40% of data points that fall within that first class. Now in the second class, your relative frequency would be 4 out of a total of 15. 4 out of 15 works out to approximately 0.267. So approximately 26.7% fall within that second class. 3 out of 15 works out to be 0.2, so about 20%, falls within the third class. And finally, the last class, we have 2 out of a total of 15. That works out to approximately 0.133, so 13.3% fall within the last class. Okay, so again, the relative frequency just gives you the percentage breakdown of your frequency. So when we add up our relative frequency column here, it should always add to 1 or something very, very close to 1. Now keep in mind that I did some rounding here for some of these values, so it's not going to be 1 exactly, but it should add to something very, very close to 1. Now in this example here, if we add up all these values, it does work out to an answer of 1. Now, one can either create a class frequency histogram or a class relative frequency histogram. It really depends on what your instructor asks for. Generally, one would create a frequency histogram, which is the second column here, as opposed to the relative frequency histogram. But again, make sure you understand what the instructor is asking for. Here, to create a frequency histogram, what we would just do is on the x-axis, we would put the drying times in minutes, because that's what the question is referring to, and on the y-axis, you would put the actual frequency. So we are plotting the frequency histogram, which means we're plotting this column here. If we were to plot the relative frequency column, that would be over here, and this would then be relative frequency as opposed to frequency. Okay, so back to the frequency histogram. What you're going to first do is put your class intervals on the x-axis. Now you'll notice this isn't starting at 0, so keep that in mind. Our first class is from 150 to 199, so I'm just going to go up to 200, and then we're going to jump to 250, and try to make your class widths roughly the same size, and then finally end at 350. Okay, so on the y-axis again, what we're going to be plotting is our actual frequency. So it's good to note what the highest frequency is in that column. Your highest frequency here is 6. So you know that your y-axis should go up to a high of 6. And so keep that in mind when plotting. So for our first class frequency from 150 to 199, our frequency was 6. And so all we have to do now is basically draw a box from 150 to 200 here in this section, all the way up to a frequency of 6. So that would be roughly right up there. Now the next frequency is 4, and that's in the class interval from 200 to 249. So we're going to draw a box up to the value of 4 on the y-axis for that class. The next class from 250 to 300 goes to a frequency of 3. And finally, the last class from 300 to 349 goes to a frequency of 2. So plot that one up to 2, and there is your histogram, your frequency histogram. Now again, if I wanted to create the relative frequency histogram, all I would be doing is changing your y-axis so that your values to be plotted are the relative frequency, and so your highest value in the relative frequency here is of 0.4, so your y-axis is going to change 2 decimals and the highest value should be up to 0.4, but the same type of shape should occur. Now with this shape, what can we notice? Well, we notice now that most of our values lied between 150 to 200. We also notice that we are seeing a right skewed distribution because it's tapering off on the right.